Hey friends, it's Scott. I want to thank our new sponsor, MailTrap, modern email delivery for developers. They integrate straight into your code with their SDKs. You get unified transactional and promotional email delivery, 24/7 support. You contact humans, not AI chatbots. We'll give you 3,500 emails monthly in the free tier, and you can try them out at mailtrap.io today. That's mailtrap.io today. Hey friends, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Chris Lattner. He's a creator of LLVM, the compiler infrastructure that underpins huge swaths of modern software. And he's also the original architect of Swift. And he's had engineering leadership roles at Apple and Tesla and Google. But now he's at Modular AI, focused on the next generation of AI native programming tools. How are you, sir?
I'm doing well, Scott. I'm excited to be here. I'm happy you finally had me on.
It only took 1,000 episodes, and
you have standards, so I understand.
True. Well, I wanted more accomplished people, so I was waiting for your Wikipedia page to scroll more.
Oh yeah, well, I mean, maybe if we don't offend you and your audience too badly, you'll have me on again sometime. So, I think a lot of things we could talk about.
Yeah, it is. It is kind of funny, though. You're right. I mean, you should have been on 700 or 800 episodes ago. So that is 100% my bad, and I will take that feedback to the team. Which is me. I'm curious though. I'm thinking about history, and I'm thinking about being, doing this for so many years, and you've been doing this for, we're kind of contemporaries. But LLVM was a research project, right? You just kind of had a Jones for this when you were a grad student at University of Illinois. Was this a long con? Have you been working on all this stuff for 30 years to get to this moment right now?
I wouldn't say it's a con. It's a passion. It's my life's work. That's probably a nice way to put it.
Yeah.
I'm a special kind of nerd. I think I am very enthralled with compute and with compilers and systems and hardware and chips and like how it all works together. But I really identify as a developer, right? And so I write a lot of code still. You can check me out on GitHub. I care about the craft. I care about what it means. I care about people developing in their careers. I care about building teams of people. I care about, building things and hopefully making an impact on the world. And so I'm good at certain things. I'm way better at building a compiler than an iPhone app or a HTML page, but that's cool with me. I just kind of try to be useful.
Did you see the AI moment coming? Like, I feel like a lot of people will say, like, as of October, now they can code for us. But like, I suspect you saw this coming a little sooner than October of last year.
Yeah, I fell in love with AI or enthralled with AI actually in like 2016. So it's about a decade ago, which makes me, I guess, a pretty old timer at this point. Mm-hmm. That was right when the Photos app at Apple was getting the ability to see cats and dogs in photos. And I'm like, how do you write for loops to figure out if there's a cat in a picture? And because of that, I just kind of fell down the rabbit hole. What is a neural network? What is a convolutional neural net? How does all this kind of stuff work? And that's actually when I was kind of getting kind of bored and ready to go embark on new things. And since then, I've been chasing what is AI? What is the developer platform? What do the tools look like? What are the systems? How do we unlock the hardware? And this has been my mission for the last decade now, which is kind of scary how that works. But
did you feel that GPTs were going to be able to spit code out as well as they can now?
Well, so the funny thing about AI, if you've been in the space, is that it's always changing, right? And so being in the AI space necessarily means that you become like acclimated to discomfort. Like you are used to things changing all around you. You never know what model or capability or demo or whatever will launch next month, right? And so when ChatGPT happened, that was a huge deal. I think that was the first wake up call for a lot of people when they started to realize that AI is a real thing. But ChatGPT for me was just the next step, right? And so what's happening, I think even the last few months, is that AI coding has really come onto the scene in a way that people didn't see coming, but it's really also the accumulation of a bunch of exponentials. And so I've been tracking the AI coding thing for over a year now. I've been using Cursor for my daily driver personally, and been experimenting with some of the agentic stuff. And it's amazing what can be done, but it is also more a continuation of the same. And so I see
Yeah.
it building. And the thing that we all wrestle with as developers now is, what does it mean? How do I best use it? What is hype? What is real? Like, do I still have purpose? And so for these things, like, again, it's not like a new question. It's more about like, what is the purpose? How do we shape our time? How do we best use the tools? And as the tools evolve, I think we need to adapt.
The speaking of, I think about every era panics. Like I remember when I went from assembler to C, and some of the old heads would tell me that like, no, you got to do assembler. Like real programmers use assembler. And then when I got color syntax highlighting, they're like, no, it's going to rot your brain, man. You can't do that. So like there's always, every era is in a panic, and you're copy pasting code directly from Stack Overflow into production. Don't do that. Recently, Anthropic announced the Claude C compiler, and you did a blog post about this just literally today, as of the or yesterday rather, the recording of this podcast. And I think we have similar takes on it. Like you said, it's an AI building a C compiler is not revolutionary, but it does tell us about like where AI is right now and where it's heading.
Yeah. Well, so when I bubble out, and just to plus one year, humans don't like change. So when I was building Swift, when we came out with Swift, there was a really interesting aha moment for me that I didn't really expect. So when we launched Swift, just contextualized, only about 250 people in the world knew about it. And so because of Apple's secrecy, it turns out most of the software engineers within Apple had no clue. And then it went from not even being on their radar to what, Apple's switching to a new language? And it was just a big head exploding moment for a bunch of people. That was fun. But the thing I didn't expect was that the existing community really resisted it. Not everybody, but particularly the people that were super expert at Objective-C, they really did not want a new thing to come onto the scene because they were experts. They really understood how to use the existing tools. People came to them. They had built their careers as being the guru. And so getting reset back to the same starting point as everybody else, being a Swift newbie, was not something that they wanted. And on the flip side, people coming to Apple platforms for the first time, or people that had been in for 6 months or something like that, are like, oh, thank goodness. Now I can actually do way more. It's so much easier. I can grow and scale faster. Now I can close the gap with the experienced people. And it's not that they're against the experienced people, but they want to get more done. I see that pattern playing out exactly today, right? Where you have a lot of people that are taking these very diametrically opposed opinions. Either AI is completely nonsense, or, oh my God, we're all doomed. But really, there's a middle path. Like neither of those is right. It's not that we're all doomed because of AI. It's not that AI is stupid. The question is, we have these amazingly powerful tools. How do we use them? And some people will deny them and say, okay, well, this is nonsense. But other people will upskill very quickly. And the people that adopt the tools and figure out the best ways to use them, figure out both AI, the good way to use it, and not the bad way to use it, because there's a lot of learning that we have to do. Like those are the folks that I think that will grow quickly, that will have new opportunities, and that their careers will progress faster and things like this. And so, to me, I always look at, not every new technology should be adopted necessarily, but this one is so obviously profound. It becomes a new tool. It's just like source control 20 years ago or something.
Yeah, profound for all things, or profound for software engineering, or do you have different levels of?
Yeah, the art of software engineering. And I think that you and I love building things, right? And so I don't see building software as writing code. Right, writing code is one thing. That is an issue, and a lot of people struggle with that. I'm at the phase where I have flow moments of writing code, like code, the syntax, like the art of like hacking stuff out on a keyboard isn't actually a challenge for me. Which, good news, I'm a senior developer or something. But that's not true for everybody, right? And so again, I think that a lot of people associate coding with the writing of code. But when you bubble out and you think about what are we trying to achieve? What are we building? Why? What does better look like? What does the architecture look like? What does good design look like? These questions are things that I think are purely human. They are something that we are innately responsible for. And I think that a lot of people, again, the extremists say, oh, well, when AI means that you don't have to know how anything works, right? The AI will just write the machine code for you. When AGI happens, all this stuff, blah, 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 like that train of thought completely dismisses the fact that it has not happened and it may not happen. And so I like to live in the real world. And so the way I kind of contextualize and look at this moment that we're in is how do we best use this technology, right? Because it is profound. It does allow us to accelerate a ton of stuff. As an experienced coder, it means I can get out of doing a lot of the boilerplate mechanical stuff. But for other people that are earlier in their journey, it means that they can be way more productive and can close a lot of gaps. So
yeah, I think about it in the context of, if you come at this with code is art and the AI is stealing my art from me, that would hurt a certain way. I don't like AI generated images. I don't like AI generated video, and I would not use an AI to generate poetry. So if the job of poetry is to evoke emotion, then I could see where one could argue in some philosophy, 201 class, that like, well, I evoked an emotion. It doesn't really matter how I did it. That's not the purpose of poetry, in my opinion.
Well, it depends on your goal. And I can't say that everybody's goal is the same, right? But is your goal of writing poetry to get paid for it? If so, then accelerating the production of poetry is probably a good thing.
But isn't that poetry slop?
But if the goal of writing poetry is to enjoy the art of building and discovering and making the poetry, then that's like saying, hey, Scott is a woodworker. Like, using a hand plane is like actually a very fulfilling thing to do. Probably not what you're going to do in a cabinet shop where you're volume producing things, right? But it doesn't mean that one is good or the other is bad. It's about what is the right tool for the job.
Right. And then that's where things get artificially broken down into ones and zeros. And by ones and zeros, I mean there's either IKEA or there's the Yankee Workshop, and there's nothing in between. Or it's like code is poetry, or it's AI slop, and there's nothing in between.
Well, and so I think that the thing that we're both channeling is that we're both artists when it comes to code. Like,
we think of us, yeah, for sure.
Yeah, and we care about the craft and things like this. I care about that for two different reasons, actually. One is, and this is something I think that people hugely gloss over in the AI discussion, is that outcomes are not the only thing that matters. It turns out that, in my opinion, building a software artifact, building something in code, is not about solving today's problem. It's about building an investment in a technology. And the thing that's always true about software is that the requirements change all the time. And so what you need both to have the outcome, but then you also need to be able to move it quickly, adapt to change, add new features, move into the new economy, add the mobile features, like whatever the thing is that you're doing, right? And so to do that, you need not just an outcome-oriented, okay, the code appears to pass the unit test, but you need people that can manage that can work with it, that can understand the considerations, that can make good judgment about where to invest and how to achieve things. And for that, you need a really visceral kind of understanding of how stuff works. I think the AI, and again, this gets back into the AI is very powerful, but it's a tool. It can encourage really sloppy work. It can encourage laziness. It can encourage a lot of really bad things. I think that we as a team, it can certainly encourage people wasting other people's time on the team. Here, I've vibe coded this thing, go review it for me, right? That's not actually a good outcome. And so I think we need to figure out how to best use these tools.
Okay. So putting all of this into the context of the C compiler, which you again wrote about recently, you call out a lot of things that I very much agree with. Like, good software depends on judgment. It feels like human judgment is the only thing that matters right now. And, good taste, or code smell, as we would have called it in the past, matters. I'll just ask you out straight. Is this a good C compiler? Did they just one-shot a C compiler, or is it a little more nuanced than that? Because it's a long article you wrote.
Yeah, well, so it's not a one-shot C compiler. They burn $10,000 worth of tokens over the course of 2 weeks. And so it's definitely a very agent swarm iterative thing, right? And if you look at this kind of agent swarm building against a objective function, it kind of looks like training a neural net itself. Like, 'cause you have a loss function of like how many tests fail, and then you're hill climbing into that. Is it good? I think it's extremely impressive as what they achieved in terms of zero human input and proving that you can match to an objective function. I don't consider that to be wildly surprising. That's what AI is good for. Like, if you look at what happened, it basically transcoded LLVM, GCC, other C compilers that it has in its training set into Rust. And so it uses the language translation abilities of transformers very effectively. But again, AI is good at that. I didn't see anything novel. I didn't see anything where I'm like, wow, that's a good idea.
But doesn't that make sense, though? Because I've been using it, like everyone knows that Claude as an example, in Opus, makes websites of a certain style. So I skinned a couple of my websites, and you can see the kind of pieces of Claude where it's like, oh, they love a text gradient, and their light modes and their dark modes look the same. And I asked my son about my website, and he says it looks mid, because he's young and everything's mid when you're 18. And but mid is the statistical fat part of the bell curve. So people are like, oh man, they stole Lattner's LLVM and they stole some GCC code. It's total ripoff. And it's like, well, no, it's the one that we all use. Like I would look at it if I were to do a compiler tomorrow. Like it's mid, not in a bad way, in the fat part of the bell curve way. It's expected. You would have been surprised if it had come up with something novel, because it's not trained on novel. It's trained on the standard.
Well, absolutely. I completely agree with you. And I both agree with you, and then I'll lean in further, right? Which is AI and LLMs are distribution followers, right? And so they're finding that midpoint in the distribution, and they can rapidly follow that. They can do some air quote innovative stuff in limited spaces, but really that's what they're designed for. But let me also give you another hot take. LLVM, like it's a good thing. I'm a fan, but it's also 25 years old and not a great thing, right? And so following 25-year-old compiler technology is actually not even that awesome. LLVM is one of the most widely understood compilers out there because there's so many people working on it and it gets used in a lot of ways, but that doesn't make it the best. And so I've been working on a lot of new compilers since then that are way better.
Okay, so that's a great point.
It's also very interesting to see that.
Yeah, because there's a mid bias, and it's like, yes, I'm going to use the last 25 years of work, but is it interesting that it didn't discover and think about Mojo and the work that you're doing there? And why did it?
Or MLIR, or these things are much more new. And so this is also where it's very funny. The LLVM community is actively working on getting rid of this thing called get element pointer out of LLVM. And so it's totally in the design for the Claude C compiler. And so again, this you can project forward and say, well, teams that proactively and actively adopt LLM-based code gen in the absence of judgment, right? Are they actually going to be held back, right? Because they're not even going to be at the forefront of tech. They're going to be, I don't know, probably not 25 years behind, but they're going to be not getting the best technology and the best outcome for the product. Now, I think the mediator on that is that not all software needs to be, quote, the best or the industry leader. It just needs to be effective. And so there's probably space for all these things.
Yeah, and there's arguably, like, they had a very well understood goal. They had a test laid out, like making one, like you said in your blog post, that it's something that a good quality team of undergraduates would come together and get a B on or something like that. Like it's pretty decent.
Well, they'd probably get an A.
I think they get an A.
It is quite a lot of work, but yeah, I mean, I think it's super interesting as an artifact. But this is also where when people jump to it's the end of times and humans are obsolete and things like this, it's obviously a hyperbole, and I don't think it's constructive, and I think it distracts from where the actual value is. So,
yeah, I think I do agree that every time some president or some billionaire person says, "Oh yeah, all of these jobs will be gone in 12 months," that's probably not helpful for anyone to be saying stuff like that.
Yeah, it's not backed up by data.
Yeah,
right? I mean, there are more programmers now than ever. The job market is actually quite hot. It's a lot of people are scared, and there's a lot of questions, right? But it's more about projecting forward, and so. This is also the question of like, okay, when AGI happens, ... Well, you can speculate whatever you want, but AGI hasn't happened, and nobody can even define AGI. So, I think that there's a lot of work to be done between now and that theoretical future.
Yeah, and will next token prediction and all the things behind it lead us into like a really smart fella or gal that's we can talk to.
But also, I mean, again, I look at AI as closing gaps, right? If you don't know what radix sort is or some exotic data structure or something like that, you don't know what a B tree is. Well, cool. Like, you can say, hey, AI, like, I have this problem. What is the best way to solve it? And it can come up with some exotic data structure, and maybe you have no idea, and it magically lifts you and fills in something that you didn't know. And that's incredibly powerful. That can lead to much better software. And so it's not BS, right? But it's also not magic. And so that's the nuance you have to find.
Well, that's a great point. Like, I like to always abuse Arthur C. Clarke and say that like each additional layer of abstraction is indistinguishable from magic. And like the stack is pretty deep now. And if you're a React programmer, the world's magic for you. And like maybe you don't even know that V8 exists as a concept. And, people tease me for my Altairs and my PDP-11s, but it's a way of staying grounded, just as you going and working on woodworking as opposed to going to IKEA as a way of you being grounded.
That's right.
As well.
Yeah. Well, the analog world's also pretty cool. So
yeah, it is pretty
knowing
awesome.
how things work is pretty cool too. So.
And everything's a conspiracy when you don't know how things work. One other thing that's I think worth noting, of course, is that they targeted CPUs, but I know that you believe that we're not necessarily in a CPU-centric world right now, and that we've got these perfectly cromulent GPUs that are out there, and so few ways to talk to them. But you're going to crack that.
Yeah. So, I mean, if you extrapolate even more, like forget about AI, go back to humans. Because I admit I'm kind of fond of humans. I don't know about you. I think that humans are actually the more important thing here, particularly at writ large. So many humans are worried about CPUs. CPUs are cool. They're very important. They run a ton of compute, but that's not where the billions of dollars of CapEx are going. That's not where all the big developments are happening. And what's happened is that, kind of you can peg it in different ways, but Moore's law ended, right? We're not getting free single core, single thread CPU performance like we used to back in the day.
Yeah.
And so we went from single core machines to, 2 cores or 4 cores. Now a cell phone has 8 cores. Woohoo. But now you have GPUs with hundreds or thousands of cores. You have ASICs that are designed for specific workloads. And let me tell you, Rust does not run on a Cerebrus system, right? That's not a thing. And so to me, I think it's really interesting. And you go back to the 2016, 2017 time for me, it wasn't just about AI is interesting. It became how do you do this effectively? And I, got AI pilled way back in the day because of the things that only AI could do back then, started by seeing dogs and cats. But then it turned into this really interesting form of compute. And one of the things that I think is just sitting there in plain sight that I'm looking at all day long that very few other people see is that, well, rewriting C code into Rust might be fun, right? But that's not actually moving the world forward. Meanwhile, we have all these crazy GPUs and all this compute out there that nobody knows how to program. And so to me, my current mission is saying, like, let's crack that open. Let's make it so it's way more accessible. Let's make it so that the tools are actually a joy to use. And by the way, even CPUs are crazy, complicated vector SIMD. They have tensor cores on your CPU, all this stuff. And most programming languages can't even acknowledge or spell float 4 or float 8 or things like this. And if you're using languages for 15 years ago, which all of at least Swift that I worked on and Rust and TypeScript all kind of came from 2010, well, then how are you programming modern hardware, even CPUs? There's just not a good answer there. And so this is where I think we all benefit from leaning into this and solving this. And that's my current mission. This leads us to Mojo and Modular and what we're doing here.
I hope I can ask this right, because I'm trying to see the big picture, and my own personal context window is still quite limited. But when I teased you earlier about the long con, I mean that in a positive way. Well, by the long con, I mean life's work is like you can kind of see down a tunnel, and you're like, you built LLVM, now you've got multi-level intermediate representation, MLIR. It's not the intermediate language from .NET. It's not bytecode, but it's a way to have a hybrid intermediate language that can have different representations and also be specific to certain hardware. Yeah. So did you know that you were kind of building these stair steps and then stepping on them, and you knew what you were reaching for? Because this is a long series of steps.
I mean, 25 years goes faster than you might think.
Yeah, but to look back and go, it's exactly as I planned. You know what I mean? Because you're building Mojo on top of MLIR, which is part of LLVM, which is part of. Like it's thoughtful turtles all the way down.
Well, so my journey is how should I say this? Like, not satisfied with the status quo ever. Like, I'm always pushing and part of the reason I left Apple is I was bored, right? And it was not exciting. And I wanted to be learning and growing and doing new things. And so amazing. I love the Apple team. I love my position and love Swift. It's a good thing. But also there's a whole world out there that's happening and changing. And so what I've been kind of on is this quest of figuring this stuff out. And so AI, I feel like I finally understand what's going on with compute.
Finally, now this is the time.
Finally, 10 years in, right? And what we need is LLVM, but for AI chips, basically. Like we need a way to program it that scales across all the silicon. We need something that's easy to use, that's familiar to people, and we need people to be able to adopt this, which means good tools and a good experience and easy to use, and like all these things that are consistent across dev tools, but in their own context. And so what that journey is, what that bridge is the world's best way to program CPUs, because that's what everybody's on. A lot of people are in Python, for example, and C++, and that's the way things are. But none of these things are actually that great either, my humble opinion. And so if you can meet people there, you can lift them, then get them onto GPUs, get them onto ASICs, and give a progressive path. I believe that we can actually crack open this gigantic compute problem. And part of my core hypothesis, which has been consistent for years now, is that if you look forward at any point in time, 5 years from now, like compute's only going to be weirder. It's only going to be more specialized, more heterogeneous, more chaotic, more fragmented. And so we as a programmer community need to have the ability to build that and use that, because you don't want to use 52 different compilers from all the different vendors that don't work together. They don't even speak the same language.
Like, not to like pull out a specific example, but it's like, I got this brand new Windows ARM machine and I was so excited. I'm going to do this. I'm going to take over the world with my Windows ARM laptop. And it's like, okay, I'm doing some Python. Now we're going to do some computer vision. And it's like, oh, now I just brought a C compiler along for the ride. And oh, that one doesn't support ARM. And oh, this wheel doesn't do this and that. And it's just like, oh man, I just want to do a thing. I want a hot dog or not a hot dog. This was not a hard hello world. And then suddenly
supposed to be.
The stack leaked. And because I was on a new processor or a new NPU or a new this, I was juggling literally Python and C# and Rust, and then like wondering where CUDA was and da-da-da-da-da. And, like you say, it all works until it doesn't.
This is the problem with these deep piles of layered abstractions where none of the layers knows how the other layer works. Right? It's beautiful in the demo, but then it falls apart when you do anything weird. Let me give you an analogy, because you and I come from a similar epoch. Most people forget what the world was like before GCC.
Oh yeah.
Right. And they don't know what autoconf was or why it existed.
Yeah.
But if you go back in time, everybody building CPUs had their own C compiler.
Yeah.
Right.
Yeah.
They didn't have AI to build it for them either. Right. And so you got the DEC C compiler and the Sequent C compiler and the Borland C compiler and the Sun and the SGI and the HP UX and all these different C compilers. C wasn't even really standardized at that point either. There was a vague understanding of what it was. And so none of them actually worked together. And what drove the world forward is when GCC came on the scene. It was free and it was portable, and it kind of scorched earth all this proprietary nonsense and it unified the world. And as a consequence of that happening, Linux was possible. Like an entire ecosystem like exploded in vibrancy and like capability because people were able to move on with life and get rid of all this weird junk. And so what I see today in the hardware is exactly the same thing. I see every hardware maker building their own stacks out of necessity. They don't really want to do all this stuff. It's actually really hard and expensive and slow. Some of them end up with a better thing than some of the other people, but none of them is compatible, right? And particularly in the AI and the GPU space, everybody's trying to take NVIDIA's lunch to a certain extent, but CUDA doesn't run on their stuff and their stuff doesn't run on NVIDIA. And so a lot of what our aha moment is saying several different factors have to come together to crack this open. One is there's the technical pieces. You can talk about being able to target GPUs and unlock the full performance of silicon and scale from CPUs to GPU, all that kind of stuff. But the other is incentive structure. You need an organization, which is modular, that is not tied to a chip. It's not tied to a hyperscaler, not tied to an LLM, not tied to an autonomous car, right?
I want to make sure people understand you're talking modular, the proper noun. You're saying modular,
Yes.
Your company, not
The company,
a modular company.
The company, my mission is formed because we need to solve this problem of having a team of people that could go and build this stuff. But then we also had to solve another problem, which is an economic problem, which is this is a really hard problem. Mm-hmm. You need a very large team.
But you just
years to do this work.
You're implying you're not in the pocket of like NVIDIA or the pocket of these people, right? Which would be able to provide all of those resources, but then they would make the default be the NVIDIA chip.
That's right. Well, and so I was at Google, for example, and I was trying to solve and crack, and I learned a tremendous amount from Google working on TPUs and scaling their software stack. Amazing team, amazing people, but it wasn't nefarious. Google's a very open source friendly community, and that's actually where we built and released MLIR, donate to LLVM. Google's amazing in lots and lots and lots of different ways. But like any business, they have their priorities. They have their internal workloads. And of course, all your best people always get sucked into the fire drill of the day. They also at the time had a performance review process that ticked every 6 months. And so projects that took longer than 6 months to do were pretty hard to justify, both up the chain, but much more importantly, to anybody that wants to get good performance reviews and wants to get, demonstrate their impact on key workloads and things like this. And so I found it to be extremely difficult to justify that work. And I'm a pretty stubborn, pretty bullheaded guy. And so yes, was able to build MLIR, was able to build a new runtime for TPUs, this PJRT thing that underlies JAX and all that kind of stuff, and made some major contributions to the stack, moving beyond what they had. But it was very, very, very difficult. And so this is actually a pretty significant challenge when you want to do something that is like a fundamental step forward in terms of languages, systems, particularly in the AI space.
Mm-hmm. You could have just taken the language and just pick one and just made Rust++. You could have made Swift. Super Swift, but you didn't do that.
That's right.
Because they were all designed for CPUs, and everyone's thinking about CPUs because that's what everyone had in 2010 when they were thinking about these languages.
Well, so funny story. When we started Modular, which is now over 4 years ago, my co-founder and I looked at each other and we said, we're definitely not doing a language. Everybody knows that languages are a terrible idea. We have a lot of stuff to get done. Like, we have a big mission of unifying compute and democratizing and unlocking all this compute, but everybody knows that's a bad idea. And so we spent almost a year working on hardcore runtimes, low-level thread pools, asynchronous communication primitives, and then dove into how do we generate high-performance kernels first for CPUs? And so in that case, we said, how do we go meet and beat Intel MKL and Intel's libraries on their own chips? Can we beat them? We need to be able to do that, and we need to be able to show generalization at scale. And so what we did was we built a whole bunch of really fancy compiler technology using MLIR from first principles. We started with an empty Git repo and built an entirely new construct and proved that we could generate very highly parametric, very powerful, very high leverage abstractions for generating high performance matrix multiplications and similar algorithms, but then ran directly into the problem of, okay, well, nobody wants to write compiler IR by hand. That's actually a really painful and very terrible idea. And so then we said, okay, let's go shopping. What syntax do we want? And I did look at Swift. I did look at Rust. I did look at Clang. Like, I know many of these systems, but to the point, they don't solve the problem. Like saying, okay, how are we going to add all the floating point data types to C? Well, AI has 7 forms of float 8, it feels like, all kinds of new forms of float 4, bfloat 16, like all of this stuff, and it's evolving at a rate that you can't just keep hard coding this into the compiler. And so we said, okay, well, clearly we need library extensibility. And so Mojo, the way it turned out is like, yeah, almost everything's in the library, not in the compiler. We also need the ability to scale across, predictability and compile time and all these things that really matter at scale for developer experience. And so these Python DSLs we looked at really were unsatisfactory. And so despite not wanting to do this, we basically kind of, as a team, looked at this and said, okay, well, building a language is a heck of a lot of work. It's also not rocket science. Like, I've done this before. Swift is a good thing, for example, but like LLVM, there's a lot of Swift the bad parts, and we can do something that learns from that experience and do something that really moves the world forward. And though it would be a long journey, we thought that, the stakes and compute and the future of all these architectures are so important that it was worth the investment.
Yeah, it feels like if you want to get something done today, you end up bouncing around from language to language. You prototype it in Python, then you rewrite it in C++ and CUDA, and then you do a bunch of bindings, and then you end up maintaining 2 code bases. So my kind of like my armchair quarterback analysis is that you kind of wanted Python ergonomics, you kind of want C and C++ perf, you like Swift style safety, but then you need awareness of things that didn't exist 10 years ago, like AI hardware. So all of those things combined, and it's not really...
While you're at it, bring in some cool new ideas like linear independent types. Let's bring in like much better ownership and memory destruction behavior and things like this. And let's move the world forward, because again, people like to zero in on Rust with ownership and stuff like this, but Rust is 15 years old. It's not. It's a wonderful thing for what it does, but it's not the best thing. So.
Yeah. Interesting. Okay, so then how do this seems like this is a vision, right? And surely this is a vision that's many years. This will come out in a half a decade or a decade, right? When do I get to actually have this though?
So this exists today. A lot of people are actually using this.
Okay.
It's in production, which is pretty cool.
It's in prod now. That's awesome.
Oh yeah. We have customer workloads that are running all this stuff. It's not a theory. Today you can run Mojo. You can download pip install it. You can run it on a wide variety of CPUs, embedded devices like Raspberry Pis and stuff like that. It's fine.
Okay.
Runs on NVIDIA A100, H100, B100, and a ton of their consumer cards. Runs on AMD, the 300, 355, their RDNA cards, which are the consumer ones, and Apple GPU. And so we have other stuff that we'll announce later, but this isn't a theoretical thing. This actually works. Mm-hmm. And one of the things that's really cool about it is, zoom back to the modern world and AI. Not only is it possible to do this stuff, but we've unified the programming model for GPUs.
That's huge because that's definitely not in NVIDIA's best interest.
Correct. Or anybody else's. It's not in Apple's best interest either, right? It's a hardware company problem, right?
Yeah.
And so we have, I think, the biggest open source kernel library that exists with all the matrix multiplications around all this hardware. It's like over 500,000 lines of Mojo code. And it's now indexable by AI. And so one of the coolest things about AI, and one of the things it's actually really good at, is translate thing A into language B. And so it turns out that if you have Python code running on CPU, we have people that are saying, hey, Claude skill, move this to Mojo, and they get 100 times, 1,000 times speed up. And
seriously. And you've got Python interop as well, right? You can pass Python objects into Mojo functions. Yeah.
Yeah, and it just works. And so this is also where, because Mojo is designed for modern CPUs, it has really badass SIMD vector support. It's natively multi-core. And so you can just kind of goad the AI tools and say, hey, can you make this go faster? And they'll say, oh yeah, I'll vectorize this for you. Oh, I'll parallelize this for you. And because all those abstractions are there, like what happens is it just like up levels your code in situ. And so you can understand it, which is really cool. And so this is where, like, we're in a different era in this co-design between what AI can do and what the language can do is, I think, it's a completely different dynamic than what we had 5 years ago.
Yeah. I think for the rank and file developers, just there's the CPU and then there's these other mysterious chips that happen to be in my computer. And to unlock that and be able to do stuff with it, even on laptops and TPUs and NPUs and things like that, is going to be huge because they're very opaque. If you start thinking, I'm going to learn how to program a GPU, good luck, buddy.
Yeah,
that is not going to be fun.
If you're interested, go to the GPU puzzles on the Modular website, and we'll teach you how to program a GPU. It's actually not that hard when you get decent tools and that actually work together. Let me tell you the bad thing about Mojo.
Okay.
So the bad thing about Mojo is it's not stable. We haven't hit our 1.0 yet. And so we've been building it for just about 4 years now. Okay. It's really cool. People are seeing amazing results, and a lot of people love it. But again, I have this burden of wanting to do something that's actually good. It's not just the outcome, but it's the design. It's the ability to scale. It's the ability to like enable new things and last for the next, hopefully 10, 20, 30 years of compute, right? And so we've been very deliberate about that, and we've been building in the open, but we're saying like, we're going to fix it. We're going to change things. We're going to laser focus in on getting to a 1.0 and stable. And the thing that I'm very excited about is that it's almost here. And so come April, May, I think we'll have our 1.0 beta. And so it's not very far away anymore, which is really exciting. Goodness. And I think we'll declare 1.0 and then open source the rest of the compiler and all this kind of stuff probably in August, September-ish, something.
Oh, wow. It's going to be a big year.
Coming very soon. And so the team's working super hard on this. I think that we all realize what a big moment this will be for the community because we have a bunch of amazing people in the community doing amazing things. But we want them to not be constantly thrashed by change. And so the stabilization point will be a big deal for us as a community.
Very cool. Mojo 1.0 coming soon. And folks can go to puzzles.modular.com. There's a really great 8-part tutorial series. You can just go through it and you can do hands-on GPU programming using Mojo. And you can do that today getting ready for the coming 1.0 in the next month or two. This is super exciting. I really appreciate you spending the time to sit down with me today.
Yeah, it's awesome to chat with you, Scott. Like I love your work, and you're a legend. I'll also say all this stuff's free, so please do join our open source community. I do love developers, and I love seeing the creative things that people can make. And this is why, coming back to the top, what I care about in the human experience is the act of creation. Being able to build something and being proud of it and saying I did that. But also, I think that many folks out there are looking at, what do I do in this uncertain future? Right? Do I just keep building the thing I was building yesterday? I mean, I think it's such a great opportunity to lean in. And again, there's this amazing form of compute, all these new tools and technologies. It's the easiest time ever to learn something like Mojo or whatever your new technology is. And so I really do encourage people to go out there and try out new things. And AI has got a lot of hyperbole and BS laden in it sometimes, but some of the stuff's also really cool.
Yeah, I really feel like it's a time where the curious are going to thrive. And I know it's scary, but craft matters. Learning still matters. Keep learning. And we just want to let you know, we appreciate you. The community appreciates you. And I thank you so much for spending time with me.
Yeah, well, thank you for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.